So here's the next one, and what we're going to do is what people commonly do. We're going to use a vulnerability scanner to find vulns and then try to exploit them. So you get your vulnerable API running. We've already got it going, and we're going to use ZAP, an OWASP product, Z-Attack Proxy. I've got it here, and I think I've got it running somewhere. Yeah, here it is. All right. So you can do an automated scan. Let me start with that. That's not, here's my ZAP. All right, there's ZAP. Let me clear my old stuff. Delete. And delete this. Okay, that gets things back to more or less the default. So here's the quick scan. There's my endpoint. So I can just run a quick scan and attack without setting anything, and we'll see what that does. Let me clear all of these if I can figure out how. I won't worry about it. Okay, we'll start the attack. So there it goes, going to my URL, and it goes to robots and such. Now it's trying some standard locations, and it's done in just a few seconds. And as you can see, it found nothing that matters. Absence of anti-CSRF token, error disclosure, content type header missing, didn't find anything useful, and that's because all it did was scan this page here, just the default page. It did not know the API endpoints, and it didn't find them. So we need to import the API endpoints into ZAP, and ZAP has that ability, just like many things. So from the menu bar, which is off screen here, I can click Import, open an API definition from a URL. And now I get a box here, and so what I do is this, the top I put in the GitHub pointing to the OpenAPI specification that we used before, the YAML file, and in the bottom I give the address of my endpoint. Now if you forget to fill in the bottom, which I did the first time, then you're going to scan GitHub, which I hope they don't get mad at me about. It didn't take too long, but anyway. That's why you have to tell it, I'm getting the definition from here, but this is the target. Anyway, that's what you do. Then you import it. So it imports the thing, 7 endpoints, it imported them successfully. And now you just attack. And now it shows you a lot more going by. Widget, tokens, user. Now it knows all the APIs. All right, and I see more questions. What do you do after add user 1? What link GitHub on that guy's code? Yeah, it just went by. Yeah, I think you saw it. That guy's code has the definitions there. So, yeah. Well, all right. So it did all that stuff, and now it found some good stuff. It found some SQL injections here. And one thing, I may have to change a flag here, I think it'll come up later. When I did it before, it found SQL injection in tokens. But when I did it before, it also found a SQL injection in uptime. And I wonder if it crashed. Now, one thing that happens with this scanner is kind of brutal. And sometimes it crashes the app. So I would, yeah, here we go. Here's the app. And it's showing some, it has a lot of error messages as it goes by. I'm going to restart it and scan it a second time and see if it works better. Because I didn't quite understand why it found the good stuff one time but not the other time. And I thought it might be because it crashed partway through. There are a lot of error messages. This is another reason why you don't scan people's things without permission, because it will fill up their error log with all these errors, because you're sending all sorts of malformed requests to it. But anyway, nope, it didn't find the second one this time either, so I'm not quite sure how I found it. Let's see, do I have to add in a token? Oh, you know, I think maybe I do have to add a token. This is a good point. I don't think I put an authorization token in, but that would be a good idea. Injection in uptime. I did not give it an authorization token. That would be a good idea, though. They would find a lot more with an authorized scan. Anyway, when I did it before, somehow I found a second one. Besides this, I found one in Uptime. And so I'll show you. Once you find these things in a vuln scanner, it's kind of a hit or miss activity, and you have to verify them manually. So let's start with the SQL injection that it found, because that's really a SQL injection. SQL injection in tokens. It found 2 of them. And let me zoom in a bit. All right, so here. If you click on one of them, it will show you, just like Burp. Let me see if I can make this bigger and still fitting on the screen. Okay, there. Whoops, that's the wrong product. Okay. It will show you here the request and the response. So what it did was it sent a user name of user 1, and the password was apostrophe parentheses. And that's what it shows you down here as the attack, apostrophe parentheses. And the response was syntax error near the apostrophe, or near the parentheses. So this is what you want to see for SQL injection. A syntax error is what indicates you have found a SQL injection. And that, by the way, was put in the password. So a apostrophe parentheses in the password causes a SQL injection. And the other one it found was a single apostrophe in the username causes a similar SQL injection with a syntax error. So we have different syntaxes for them, but we have a SQL injection in the username and in the password on the tokens request. So the way to verify this thing is to go to Postman, which you've already got set up, and here is the tokens request that gets you a token. And so I've got username and password, user 1 and pass 1. If I send this one, that works and I get a token. So it said if I put a single apostrophe in the username, I'll get this mess, which is a syntax error near pass 1 if you view it like a web page. So that's the SQL injection, apostrophe there. Okay, and if I get rid of that and put in user 1 again, and if I go to the password and I put in apostrophe open parentheses and send that, then again I get a syntax error. So I've got a clue what's going on here. So now I should be able to get away with murder here by replacing things. So for example, if I put in an apostrophe parentheses and get a syntax error, if I put in instead the classic one, apostrophe or 1 equals 1 and then dash dash, the dash dash should comment everything out after this, and so this might be a magic password. So let's send in user 1 and that password, and now I get an access token. So I did not have to put in the right password. Just putting in that injection got rid of the password. Now, if I want to get passwords for other people, like user 2, I tried this, user 2, and then when I send it, it tells me I got something, but it's still just giving me user 1. I always get user 1, so that's annoying, and I struggled with it for hours today, and I finally realized this is simple, and it was in one of those Web Security Academy projects. The solution is user 2 apostrophe dash dash. The query is select star from users where user equals username and password equals passname. If you put the comment here, it will not check the password anymore. It will just check the username. So I tell it user 2 apostrophe dash dash, and now I get a token for user 2. So I can get a token for anybody I want. And I can get a token for an admin account by giving it admin 1 here. And now I've got an admin token. And with the admin token, I can create a new account in the create user. So, then you've really got a lot. So that's pretty exciting what you can do with the SQL injection. And there was another vulnerability, which I found, although when I tried to scan it again, I couldn't find it. So there's something not quite right here. But the other thing it pointed out was this thing we've never used yet called display uptime. And the scanner incorrectly flagged this vulnerability as a SQL injection, but but in fact it's pretty obvious that it is a command injection. If you run display uptime, it's a get uptime, you send it, and the response here is incredibly simple. It just is command uptime, and this output is the output of the Linux command uptime. It just tells you how long the server has been up. So that strongly suggests that this is just executing a command line command. And this second method here, display uptime flag, has got two parameters. It's got the uptime here in the URL, and then it has a flag, which he's filled in with just random junk here. But if you put in, this is a command line parameter. If you put in an H, for example, for help, and then send this one, it will, the command is now uptime -H. And now you get the help message for uptime. So this is like the ping command we did at the start of this class. It's taken something which I put in, the H, and just put it in the line of a command. So all I have to do is like H semicolon, I can put in anything like who am I. I can put in any Linux command there and send it. And now it tells me I'm Debian. And so I could put like date. And see, there's the date. So you got simple command injection right there. And someone says, what does -- mean? I don't know what -- you're talking about. Anyway, so that's the verification of that next one, and you can exploit them. So that's all I wanted to show you about that one. Can you get a shell? Yes, you certainly can get a shell. I didn't try, but you certainly could get a shell by executing the correct command line commands. I've seen a variety of them. There are one-liner bash shells you could use, and you could use curl or wget to download malware and then execute it. Sure, I mean, you got command injection. You could do any of the stuff. To get the administrator password, I see a question. All right, to get the administrator password, the way I did it was go to get token, and I see what you're saying. Here, you put in the name of the administrator and then apostrophe --. The apostrophe ends the name of the administrator, and the -- starts a comment, so it ignores the rest of the query and it doesn't check the password. So let me actually put this up in a text box so you can see it. This is real important. This is the heart of SQL injection. So the command is, let me make this nice and big, is, I'm trying to make it big if I can find the right keys to press. Okay, select. The command is like this, star from users, where username equals username and password equals pass. There. That's the command that's running. Let's make this normally be capitalized. Okay. So this is what's going on. And when I do the injection, it turns into this. I put in user2 apostrophe --. And what happens is the -- begins a comment. So none of this matters. And now it's just username equals user2, and it doesn't look at the password. So now I get the information, and so to get admin, I just make this admin1, and I will get the administrator token without knowing the password. The -- is super important, and so is the apostrophe. The apostrophe is the SQL injection that allows me to add characters that will be treated as commands, not data, and the command I put in is comment, which gets rid of all this. So that's the injection that lets you get other people's tokens. And by the way, you can then go back and get their passwords from the previous function. Now that you have their token, you can go back to the user container here and get their passwords. So it's pretty awesome. You can totally compromise the app that way. And with the command injection, you can totally compromise the server. As you point out, you could get a shell and then you could do anything you want on the server. So it's good, clean fun. And that's it for that demo.